So hopefully you've practiced the ones that have a common denominator so you get that rhythm of how to add and subtract numerators and then how to simplify. Now we're going to talk about how to create common denominators. So we're going to start with monomial denominators and then we'll move up to binomial and so on and so on. So with a monomial denominator, we're going to start without fractions. I'm going to say these are both of our denominators. How do you find a common denominator? Well, I look at each thing in turn. So I look at the 2 and the 6 and I think what's the lowest common denominator? So what's the lowest number the 2 and 6 both go into? And that would be 6. And then I've got an a squared in this term and I don't have an a term in this one, or an a variable. So I'm going to make sure that my common denominator has an a squared because you can't get rid of things. And then I have a b and I have a b squared. So I'm going to give it a b squared. So you always have to take the highest variable. So when you're doing a greatest common factor, it's the lowest exponent. When you're looking for a lowest common denominator, it's the highest. In other words, I could multiply 2a squared b by 3b to get 6a squared b squared, to get that common denominator. I can multiply 6b squared by just a squared, and then I get that 6a squared b squared. So you're looking at what is the lowest common denominator and what do I need to multiply by to get that lowest common denominator. So if you look at these two, I've got a 10 and a 15. So my lowest common denominator is going to be a 30 because 15 times 2 is 30 and then 10 goes into that. Then I'm looking at my x's. You take the highest exponent, and my y's, I take the highest exponent. So to multiply, what do I multiply 10x cubed by to get this? I'd have to multiply by 3y squared. That would give me 30x cubed y squared. This one I'd have to multiply by a 2 and an x to get 30x cubed y squared. All right, pause the video. See if you can find the common denominator for these three monomials. Okay, hopefully you gave that a go. So we have 3, 6, and 9. So the first thing I always check is I look at the highest number. Does 3 and 6 go into 9? Nope. So then I double 9 and I get 18. Do 3 and 6 go into 18? Yes. Then I have to make sure all the variables are there. So I have an x, I have a y, and I have a z, and they all have exponents of 1. So this first one I'd have to multiply by 6z. This second one I'd have to multiply by x, and this third one I would have to multiply by 2y. And then each of these would give me 18x, y, z. Okay, so now that we've practiced creating common monomial denominators, let's do it. So here's the first question. So I've got three denominators, 5a, 2a squared, and a cubed. And you could write them over here. You know, if you liked the way that that was done in the last section, write them. Figure out what your common denominator is. Now, everybody will do this next step a little bit differently. I, over the years, try to do this in the cleanest way possible, showing the most steps I can, but with the least amount of writing. And what I've found that is that I write my common denominator. So if I have a 5, a 2, and a 1, my lowest common denominator is going to have a 10. And if I have an a squared, and an a cubed, my common denominator is going to have an a cubed. Then I'm looking at what do I have to multiply this term by to get 10a cubed? Well, I'd have to multiply by 2a squared, top and bottom. So what I write here is I write the 4, and then I go times 2a squared. And then I write the minus 3. So I'm taking my numerator, and then I'm writing what I need to multiply it by. So to turn 2a squared into 10a cubed, I have to multiply by 5a. And again, what I'm doing to the bottom, I'm doing to the top. And then this guy, I want 10a cubed, so I have to multiply by 10 over 10. So I have plus 1, and it's getting multiplied by 10. So I actually don't show the work that I did up in here. I write it like this, and after watching a bunch of students, I find that when you get used to doing this, it makes everything cleaner, and you actually end up quite liking it. But if you're someone who wants to show your steps, you know, this way, where you show multiplying the top and the bottom and then doing it, just be careful with these minus signs in the end. I like this method because then the minus sign just sort of comes with the numerator. So what I mean by that is we've got 10a cubed on the bottom. On the top, I'm going to simplify. So 4 times 2a squared is 8a squared. Negative 3 times 5a is negative 15a. And then 1 times 10 is 10. Then I'm looking to see if I can simplify it all. So the only way I'd be able to simplify is if something came out of 10a cubed that also came out of each of these terms, and this 15 kind of throws that for a loop. Without the 15, I could maybe take a 2. I can't take a 5 because the 8. I can't take an a because this one doesn't have it. So this one is actually fully simplified, and that is your final answer. All right, let's try another one. And you could pause the video and try this one if you feel ready. If not, you can watch another one. So in my work, what I do is I draw a big line and I figure out what my common denominator is going to be. I have an x squared y, I have an xy, and I have an xyz. So my common denominator is going to be x squared yz. So x squared yz. Then I figure out, what do I have to multiply each of the numerators by? So I can even write it like this to start. And again, it just makes your work cleaner. It's not necessarily the perfect way to do it. It's the way that I have found that I like to write my work. And from watching students, I find it's the way to get them to do the work correctly. So I've taken each of my numerators and written them in there. And then I'm going to write what I have to multiply them by. So x squared y, to get x squared yz, I just need a z. Xy, to get x squared yz, I need an x and a z. And then xyz, I just need an x. And then I simplify. I've got 5 times z is 5z, minus 3xz, minus 1 times x. And in my denominator, I've got x squared yz. And again, you'd want to see if you can simplify. So you're looking if there's any greatest common factor that can come out of here, because right now I can't simplify because of the minus signs. But if I could change it to a multiplication by factoring, then I could. But there's nothing that can come out, and so this is fully simplified. All right, the next kind of denominator is when you have polynomial denominators, so not just a monomial anymore. So your denominators could be m squared minus 16 and m squared plus 8m plus 16. And your first step to finding a common denominator is to factor. So m squared minus 16 is m plus 4, m minus 4. It's a difference of squares. M squared plus 8m plus 16 is a perfect square trinomial, and it would factor down to m plus 4 all squared. So we do the same thing. You're looking at making sure that each of the factors is present. So you have an m plus 4 and an m plus 4 all squared. So your common denominator, you have to take the highest exponent. And then this one has an m minus 4. So you'd have to multiply this guy by m plus 4 to get that m plus 4 all squared. And this one you'd have to multiply by m minus 4. Okay, looking at these ones, again, I've done the factoring for you just to kind of make this a bit of an easier process, but the questions could have started with these denominators. Your first job will be to factor, and then you have to look for what the common denominator would be. So I'm looking at these coefficients, so this guy would have a 4, and then I have x minus 1 squared, and then I have this x minus 3. So this one would have to be multiplied by the 4 and the x minus 3. This one would have to be multiplied by the 4 and an x minus 1. And this one would have to be multiplied by an x minus 1 and an x minus 3. I mean, this is worst case scenario. This would be a pretty complicated question, but it does happen. This would be kind of the end of your homework. So let's start a little bit simpler. So objective 3. I have two terms here. This one has a denominator of y. This one has a denominator of y plus 4. You can't add to get a common denominator. You have to multiply. So my common denominator is actually going to be y times y plus 4. Then I take my numerators and I write them out and I look to see what they need to get multiplied by. So this first term would have to get multiplied by y plus 4. The second term would have to get multiplied by y. And then I simplify. So I'm going to multiply through the top. I get 2y plus 8 minus y. I don't ever multiply through the bottom. And the reason why is that this is already simplified factored form, whereas your numerator, we're simplifying to see if we can factor. So this would give me 2y minus y is y plus 8 over y times y plus 4. And since this binomial does not match this one, you can't simplify. The y's can't go because this isn't y, this is y plus 8. This is fully simplified. All right, looking at this guy, I have an r minus 2 and an r minus 1. So my common denominator will be r minus 2, r minus 1. So then I take my numerators, and I look to see what I need to multiply them by, and carrying this minus through. So this minus has to go through the whole numerator, which is why I put that in a bracket. So this first term has to get multiplied by r minus 1. This second term has to get multiplied by an r minus 2. And then I simplify. So your bottom is already simplified and factored. Your numerator needs to be done. So this would be 2r minus 2. I'm going to leave that minus there, and I'm going to multiply this through. So I get r squared minus 2r plus 3r minus 6. And I'm going to keep going. I've got my denominator, r minus 2, r minus 1. In my numerator, I've got 2r minus 2 minus r squared plus 2r minus 3r plus 6. Simplify further. I'm going to write them in descending orders of power. So I've got negative r squared. That guy's gone. 2r plus 2r is 4r, minus 3r is plus r, and then minus 2 plus 6 is plus 4. Then I'm going to look to see if I could factor this. Now I can tell right away I can't, so this is my final answer. But if I tried, the first thing you would do is factor out that negative 1. Oops, minus 4. And if you did this step, you could leave it like this too, it wouldn't matter. But I'm looking for two numbers that multiply to give me negative 4 and add to give me negative 1, which won't happen. So negative 4 and positive 1, negative 2 and positive 2, they can't multiply to give you negative 1. So this is fully simplified. So this would be the perfect answer. If you did this extra step and went to here, that's fine too. Both of these would be acceptable. All right. Keeping on moving. I'm wishing I took a break after that, after that other monomial, but let's just keep plowing through. So we're looking for a common denominator here. Now this guy's set up to sort of trick you and see if you notice. So there's two ways of simplifying this one, but you see that we have a denominator of x minus 3 and a denominator of 3 minus x. Well, what if I wrote this as x minus 3 and negative x plus 3? In fact, what if I wrote this as x minus 3 and negative times x minus 3? Can you see that these could be common denominators? In other words, if I rewrote this as 2 over x minus 3 plus 1 over negative 1 times x minus 3, if I factored out that negative 1, what you can do is rewrite this as 2 over x minus 3. This minus sign can be bottom, middle, or top. So you could do plus negative 1, or you can actually just change that plus to a minus. 1 over x minus 3. I've got a common denominator of x minus 3, and then I've got 2 minus 1 is 1. And that's fully simplified. That's kind of a great question. If you didn't see that and you made your common denominator x minus 3 times 3 minus x, it will work. You'll do a lot of work and then you'll end up with this answer. So I really wanted to show this one because if you ever end up with denominators that are the same but reversed, just factor out a negative 1 and they're the same. All right, next question. We have a denominator of x minus 5. We have a denominator of x. And then this guy I'm going to factor to x times x minus 5. And so this is what should happen. If it looks like you're like, oh my goodness, I have 3 denominators, seriously, I have to do that, don't forget to factor first. Chapter 6, the main word for chapter 6 is factor, 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 factor. Anytime I see an exponent, I think factor. So that my common denominator is going to be x times x minus 5. So if I look at this one, I mean, I didn't write this. I mean, I guess if I was being a perfect teacher, my first step would be to do this. There we go. Now I feel better. Okay, but in reality, I could see that my common denominator is going to be x times x minus 5. So again, take your numerators. When you have plus negative 2, it's just minus 2. And then minus 10. So what do I have to multiply this first term by? I have to multiply it by x. So top and bottom. This one has to get multiplied by x minus 5. And this one doesn't have to get multiplied by anything, so just a 1. And then I'm going to simplify. I get 4x minus 2x plus 10 minus 10 all over x times x minus 5. Again, the bottom is simplified and factored for you. And then simplify further. 4x minus 2x is 2x. 10 negative 10 is gone. And then I can see this is in factored form, everything's multiplying, there's no plus signs to stop me. This one would stop me unless I had another x minus 5 factor, but I can do x divided by x is 1, and I'm left with 2 over x minus 5. And don't forget, I mean, these are a lot of work, but you can always check. Don't choose a 0 or a 5, but if you plug any other number in for x up here, and then again down here, you should get the same value because this is a simplified expression of your original. All right, last couple, and then we're going to be done 6.2. So with these ones, the only trick is the first thing you're going to do is factor. So I'm going to take this negative and I'm going to bring it up here when I do this. So I'm going to write negative a, because negative signs can go top, middle, or bottom. Always easier with fractions to put them on top. So I'm going to factor this guy. It's a trinomial, a. Two numbers that now multiply to give me -4 and add to give me +3 are +4 and -1. Again, if you're still doing AC method, feel free to do it. Just do it on a separate piece of paper and write the factored answer in here. Then I've got -4a all over, and I'm going to factor this guy. So I've got an a and an a. Two numbers that multiply to give me 12 and add to give me 7 are 4 and 3. So I'm looking for what my common denominator was going to be. So again, if you found that beginning thing helpful, do it. So I've got an a plus 4 and an a minus 1. I've got an a plus 4 and an a plus 3. So they already have the a plus 4 in common. So this one's going to need the a plus 3. This one's going to need the a minus 1. And then they'll have the same factors. So I'm going to write that as my common denominator. So a plus 4, I only need one of them. And then an a minus 1 and an a plus 3. There's like 1% of the questions where you might have to multiply the numerator by 2 binomial brackets. Most of them it'll turn out if you factored correctly, you'll only have to multiply each of them by 1. So you've got your -a that you're going to get multiplied by something, and you've got your -4a that's going to multiply by something. So the -a is going to multiply by that missing a plus 3, and the -4a is going to multiply by that a minus 1. Now the only drawback of this method I see, and I'm only going to mention this once, is that I see people going, oh, a minus 1, now it's gone. A plus 3, now it's gone. Are you allowed to do that? It's an honest question. Can you do that? And the answer is no, because the a plus 3 isn't a factor. It's part of this term, and there's another term here, so it's a binomial. So the a plus 3 has to get multiplied by all of these things, just like this one does. In fact, right, what would prevent that is going, hey, a minus 1, and then going a plus 3, a plus 3. And then you can see that maybe then you won't make that mistake. So the only downside of this method that I show, where I like it clean, it's showing a lot of steps without having to write a lot, is that I see some people just fully simplifying wrong. So if you're someone who's going to do that, don't do it this way. Go back to here, simplify, and then combine your numerators together once you've multiplied through, but do not go like that. Okay, I hate saying things out loud. Some people think when I say it, it puts that into your head and then you want to do it. Don't do it, okay? Just simplify. So you get -a squared minus 3a minus 4a squared plus 4a all over a plus 4, a minus 1, a plus 3. And again, I think that this method comes from me just being lazy. I don't want to write this binomial or this huge denominator twice. So I write it with that common, and just don't make mistakes. So -a squared minus 4a squared is -5a squared. -3a plus 4a is plus a, all over a plus 4, a minus 1, a plus 3. Now I can look at this and see that it's fully simplified, but you might look at it and say, oh my goodness, the top can be simplified, it can be factored. We'll do it. Take out maybe a -a. You'll be left with 5a minus 1 over a plus 4, a minus 1, a plus 3. But you can't simplify anything. This binomial factor is not the same as any of these binomial factors, and there's no simple a. So this is a perfect answer. If you went that step further and factored, this is just another form of that one, so it's great too. I would accept either. All right, this last one I recommend pausing the video and giving a go and seeing how you get with it, and then unpause. So if I give it a go, I'm going to factor my denominators first. So I have P and a P. I'm looking for two numbers that multiply to give me positive 9 and add to give me negative 6. It's going to be negative 3 and negative 3. For this one, I got a P, I got a P. I'm looking for two numbers that multiply to give me negative 15 and add to give me 2, which are positive 5 and negative 3. I've got my 4, I've got my 1. So my common denominator, if you look at it, you've got a P minus 3 all squared, and then you've got your other term has P plus 5 and P plus 3. So your common denominator is going to be P minus 3 all squared and a P plus 5. So for this one, it needs to be multiplied by that P plus 5. The plus 1 would have to get multiplied by the P minus 3. And then we simplify. Multiplying the 4 through, you get 4P plus 20 plus 1P minus 3 all over P minus 3 all squared times P plus 5. And then you're going to simplify. So 4P plus P is 5P. 20 minus 3 is 17 all over P minus 3 all squared and P plus 5. And again, I would try to factor this to see if I could simplify it down to a binomial factor that could simplify, but there's no greatest common factor between 5 and 17, so it's done. So it's a lot of work, and again, I probably should have paused after I did the monomial denominators, but it just felt like a really short lesson. Take these in pieces, give them a go. If you don't like what I did, if you don't like the way I showed my work, there's videos online that you could go and watch that will do it differently. You know, they'll do it kind of more maybe like this one, where I show what I multiply by individually, and then I get my common denominator, and then I combine my numerators, and that's really the only difference. So, you know, if this isn't making sense to you, it is a hard topic, go and find another video to help you out.